Okay, now in this next little mini vlog, we're going to find some quotients we're going to divide. So the square root of 4 is a perfect square, it's 2. Okay, so we have 8 divided by 2, and 8 divided by 2 is 4. That's easy. But now this is going to get a little bit more difficult. Okay, the square root of 2 is an irrational square root. Okay, so we put in the division sign and see if 2 divides by any of the perfect squares. Well, the only perfect square 2 would even be divided by is 1. So we're just going to leave that, but here's the thing. When you have a division problem, you can't, or a fraction or division, whatever you want to call it, you can't have a square root on the bottom in the denominator. Okay, this is the numerator, this is the denominator. Okay, what you need to do if you have a square root in the denominator is do what's called rationalizing the denominator. And it's not hard to do, but here's how you get the square root out of the denominator. You put times and times, just put a times over the division sign. And you're going to multiply the top and the bottom by the same thing, and what you're going to multiply it by is the square root that you're trying to get rid of. Okay? Now, we can't, the top, don't take 8 times 2, because 8's a coefficient, 2's a square root. So what you do is you just put 8 square root 2. Now, here's what happens on the bottom. Okay? Now, bear with me here. The square root of 2 times the square root of 2, we can multiply these because they're both in square roots, is the square root of 4. Okay? You have a square root. And 4 is a perfect square, that's equal to 2. Okay, so we have 8 square root of 2 divided by 2. Now I divide the two coefficients, circle that, and we divide 8 by 2, and that's 4. Okay, so 4, and then we put the square root of 2 next to the 4. And there's your answer, that's your quotient, 4 square root of 2. Okay, we'll have to do more of those obviously. Not on this one because 4 is a perfect square. It's not irrational, so the square root of 4 is 2, so we have 10 divided by 2, and that's 5. Okay. However, the square root of 5 is irrational. The only thing 5 is going to divide by is 1, okay? So 5 is not divisible by 4. 5 divided by 4 is a decimal. 5 divided by 1 is 5, but that's stupid because it just ends up the same thing. But we still have to rationalize the denominator, okay? So you do not want that square root on the bottom. So you're going to times the top and the bottom by the square root you're trying to get rid of, the square root of 5. Now the top you don't actually multiply because that's a coefficient, that's a square root. So you put 10 square root of 5. Now, on the bottom, the square root of 5 times the square root of 5 is the square root of 25. You can multiply those, and 25 is a perfect square. That equals 5. Okay? So we have 10 square root of 5 divided by 5. So then we can divide the 10 by the 5 to get 2, and then square root 5, just like that. Okay. Okay, 18 divided by the square root of 9. Well, the square root of 9 equals 3. 9 is a perfect square, so it's just 18 divided by 3. 18 divided by 3 equals 6. But the square root of 3, that's irrational. So you can try to divide it, but the only thing 3 is going to be divisible by is 1. Okay? So we leave that as a square root of 3 if the only thing it divides by is 1, but we need to remove the square root from the denominator with the procedure known as rationalizing the denominator. Now I'm going to show you a little quicker way to rationalize a denominator. It's really easy. You notice how we took the square root of 2 times the square root of 2. It was the square root of 4 and it ended up as 2. You notice how here we took the square root of 5 times the square root of 5. It was the square root of 25 and it ended up as 5. Well, here I'm going to have 18 square root of 3 on top. You don't multiply those, you just put them together. Now if we multiply square root of 3 times square root of 3, I'm guessing it's just going to be 3 without the square root. Yeah, because it'd be the square root of 9. 3 times 3 is 9, but that equals 3. Anytime you multiply two identical square roots, it just ends up as the value without the square root. And then 18 divided by 3 then is 6. So 6 square root 3. So let's do it like that so we don't take as much time and jumble up our paper. 15 divided by the square root of 2. Well, the square root of 2 is irrational. Okay, 2 is not a perfect square. 2 only divides by 1, so we're not going to be rewriting it into 2 square roots when all it divides by is 1, so we need to rationalize the denominator. Rationalize denominator. So you multiply the top and the bottom by the square root of 2. 15 times the square root of 2 is just written as 15 square root of 2. Square root of 2 times square root of 2 is just 2. Okay. You can divide these. 15 divided by 2, 7.5. You can put that. And then square root of 2. Or you can leave it, or if it's a decimal, you can just leave it as 15. You can just circle it if it's a decimal. Okay. Why don't we do that? If we divide this and get a decimal, why don't we just leave it like this? Okay. Or if you do the decimal, I don't really care. I don't know why this is there. That's okay. Square root of 36. Well, 36 is a perfect square. That equals 6. Okay. So we don't have to rationalize the denominator. We just take 6 divided by 6, and that equals 1.